I am again. Here I am again. Just checking that everything is working. Let's see. Chop, chop, chop. Come on, physics boys. Don't we all love a bit of physics before the exam? Come on. Star, you are here again. Oh my god, so you want to attend to a very hardcore physics lesson. I hope you are aware of what it's gonna do to your soft young brain. Who else is in here? That is very beautiful. That is very nice from you. Okay. Oh my god. That was a good answer. That was a good answer. No idea where are the deeps. I want to share with you then an exam paper. Boop. Here we go. And so, what is the topic we are going to do today? Do we want to do particles? Do we want to do waves? Do we want to do multiple choice? What do you think would be the best thing to do? A 6-mark question. This one is actually very nice. If you have this question tomorrow, it will be something to celebrate. That's a long-term project to cover all the topics in GCSE and A level. Let's see what my students they want to do. So let's see what they want to do. What should we cover? Particles, waves. I'm doing a poll, just give me a second. Multiple choice. Let's see what you think. There you go, a poll. If you could please answer, that would be very appreciated to see what people wants to do now. This is physics, A level, okay? No mechanics. Mechanics, no. As I mentioned before, I used to be very good at mechanics, but because I have not taught that in 6 years, I have lost the magic. I have lost the touch. But I used to be very, very good at mechanics. Let's see the results. Let's see what you want to do. It's just skill issue. Could be. Alright. So multiple choice is the winner. Multiple choice is the winner. Alright. Let's go to multiple choice then. We scroll down to multiple choice. This exam was very beautiful actually. I really like this exam. This was 2020. I remember very well. Wait, where are the multiple choice? Ah, silly me. This is not A level. This is AS. Sorry. PMT past papers A level physics. Sorry, I took a AS paper, not A level. Silly me. Nothing that we cannot solve quickly. We will go quickly to PMT. Lovely website you are all very familiar with. Scroll down quickly and we will do the one for 2020. Okay? Thank you for your patience. Very, very quick. Pom, pom, pom. Chop, chop, chop. Come on. We did 2020? I don't remember doing with you 2020. Yeah. 6 years ago, I was not 14. I was actually 24. Alright. Here we go. Is this familiar? Is this something that you are familiar with and you don't want to do it? I think it's a good paper. I think it's a good paper. No? Or we should change the... We should change to a different year. We can do it. Yeah, it's not like you know the answers by heart, right? It's not like you know the answers by heart. No, I'm not talking to... No, I'm talking with your older brothers. I'm talking with your sixth formers. Obviously, you have never seen this. Let me make it a bit bigger. So, question number one. Question number one. Mechanical power. Is it a vector? Is measured in joules? Has a base unit of kilogram meter squared divided by second to the power of 3. Can be calculated from force times distance. What would you say? What would you say? What do you think is the correct answer? Yes. The answer is C, as per you. Ooh, sorry, I hit the microphone. But would you be able to explain why? No, it's not E. It's not E. No, it's not D. It's actually C. But you should be able to explain why. Okay? You should be able to explain why. Yes, it is C. It is C. But we need to be able to explain the demonstration. We need to be able to... Sorry, I will move the camera. Because clearly I'm not pointing at myself when I'm reading the chat. Like this? Okay, like this. We need... No, it's not D. It's not D. It's C. Okay? Alright. I will leave it to you to try to demonstrate, but no, it's not horsepower. It's based on the demonstration that we did in our last lesson, okay? Water waves of wavelength, lambda, and wave speed v are related by v is equal to the square root of k divided by lambda, where k is a constant. What is a possible international system unit for k? And no, power is not a vector, that's for sure. Yeah, but it's physics A level. Okay? What would be the units for K? Well, this is something we can do. Let's see if we can do it in here. So, V is equal to the square root of K times lambda. Is it lambda? It is lambda. Okay. So, let's substitute what we know, okay? V, the units are meters per second, correct? And here, lambda is in meters. So what do we have to do? So when we do that times something, and we do that square root, the result is meters per second. It could be meters per second square. So when we do then meters per second square times meter, that gives us meters square divided by second square. Square root of that, meters per second. Alright? This one is very, very easy. Very, very easy. If they give us something like this, we will honestly celebrate that. I hope this is one of the units, otherwise I will be humiliated. So, yes, it's A. Okay? Did anyone say A? Yes, well done, CG man. Well done, CG man. I'm proud of you. Okay. A photon, I love all the questions about photons and everything. A photon has energy 1 times 10 to the power of 18 electron volt. An object of mass 0.03 kilogram has kinetic energy equal to the energy of the photon. What is the speed of the object? Okay. So, first of all, what we need to do is to turn the energy from electron volts into joules. Okay? We cannot use electron volt. It's a very comfortable unit when we are talking about electricity, but it's not useful when we are talking about energy in terms like a general concept. Okay, 1 electron volt in joules, if you remember. Let me put the camera. Okay, so here it is. So 1 electron volt is equal to 1.6 times 10 to the power of minus 19 joules. Okay, that is important. No, we don't use E is equal to mc squared. Remember that this is paper 1, so nothing about radioactivity. Okay, the one we need to use is, they are saying that the energy of the photon is equal to the energy of the object. And they said that the mass of the object is 0.03 kilogram, and this object is moving at a certain speed that gives it the same amount of energy that one photon with that particular energy. What is why? So you're telling me I have to learn this after year 11? If you want to do physics A level, definitely, yes, of course. Okay. Anyway, so what we do, we put both of the equations we have to calculate energy together. So the energy of the photon will be equal to Planck constant times the frequency, and this one is going to be 1/2 mass velocity square. We don't need to do this one because they are just giving us the energy directly, and they're saying that the energy is 1.0 something. Did they say no, just 1 point. Yes, they are saying that the energy of the photon is equal to 1 times 10 to the power of 18 electron volt. So this 1 times 10 to the power of 18 electron volt, we need to do times 1.6 times 10 to the power of minus 19. We need the energy in joules. So is 1.6 times 10 to the power of minus 1 joules. We don't need calculator actually. And this is going to be equal to the energy. No, we are not talking about the speed of light, guys. They're saying that we have an object that has the same energy as one photon that is going that has this energy. Okay, we are not talking about speed of light. This object is not moving at the speed of light. What we are saying is that we have an object that has a mass of 0.03 that has that amount of energy. So now we do 1.6 times 10 to the power of minus 1 joules, if you prefer 0.16, better, joules is equal to 1/2 times the mass, which is 0.03, times the velocity square. So the velocity square, there's no velocity square. Let's simplify this. It's equal to 2 times 0.16 divided by 0.03, and that square root. Very quickly with our calculator, that is, some people are saying that is 3. I'm not saying that you are wrong, okay, but I just want to double check. 0.32 divided by 0.03 and the square root of 10.6666. Sorry, I don't have a calculator. I actually have my phone. 10.666. Yeah, it's like 3. It's like 3.3 meters per second, which obviously in terms of the answer to the question is B. Okay, so you see, it's not always C. It's not always C. If now you go to the exam and you just click C, you're gonna fail miserably. Easy peasy, lemon squeezy. All right. A deuterium nucleus and a tritium nucleus fuse together to form and to produce helium nucleus and a particle X. What is X? And this is relevant also for those who are studying GCSE, because we are talking about fusion, okay? And in fusion, we have two light elements, then they come together. By the way, this is obviously happening at very high speed and very high energy, okay? And they form a heavier element. And this is an example of a chain reaction. So it's a reaction that happens on its own. And obviously the answer is, as they are saying in the chat, is B. Yes, it is correct. This produces neutrons, which later on they will continue with the reaction. Okay? Similar to what happened in fission, but in fusion is two light elements together. The radioactive nuclide of thorium, which by the way now thorium is being used in but neutrons they don't have charge. So look, helium has no charge, tritium has no charge. Sorry, deuterium, which is hydrogen, has no charge, tritium has no charge, helium has no charge, neutron has no charge. So it is conserved, okay? Anyway, what I was saying is thorium nowadays is being used in nuclear power plants, which is something quite cool. So we have thorium that decays by 1 alpha followed by 2 beta. What is formed? Let's go to the... Okay. So we have thorium 232 90 1 alpha, it turns into 228 88, whatever, I don't care. And then 1 beta plus alpha, and then this one goes through 1 beta. In beta, 1 neutron is tired of being a neutron and turns into a proton. So now we're gonna have 228 89 y plus beta, and then this one goes through another beta again and is 228 90, and is back to thorium. Okay, back to thorium, but it will be an isotope of thorium. Okay, it will be a thorium with less neutrons in this case. Okay, which is answer C. All right, again, this case is C. What quantity is measured in kilowatts per hour? Or kilowatts hour, better say. What do you think, ladies and gentlemen? Do you think you can answer one question without me? Yes, it's also C, energy. Well done. Well done. Number 12. An electron collides with an isolated atom and raises an atomic electron to a higher energy level. Which statement is correct? The colliding electron is captured by the nucleus of the atom. That is not correct. A photon is emitted when the electron rises to higher energy level. Not correct. Because actually, when an electron goes to a high energy level, the electron absorbs energy, does not emit energy. Obviously, it has to absorb it. An electron is emitted when the excited electron returns to the ground state. That is also false. An electron is not emitted. Radiation is emitted. When one electron that is higher moves to a lower one, radiation is emitted. That is the reason of the colors that we see around us. All the colors, this red in my microphone, this green in my camera, this brown in here, that is all due to electrons moving up and down into energy levels. Last one is correct. The colliding electron transfers energy to the atomic electron. That is the correct one. Okay? It's obviously D. Okay, which graph shows the variation of momentum P with the wavelength lambda of a photon? Look again. Okay, let me see if I can put the 4 of them together. Okay, I will just give you a hint. Remember that wavelength is inversely proportional to energy. Is it a bit robotic? Maybe I'm just turning into a robot. Am I turning into a robot? No, I'm not a robot yet. Okay. Why do you think is not B? Because momentum in this case is not gonna be 0, okay? Or it cannot be 0 in this case. Because the photon is moving. Therefore, it has velocity. And if it has velocity, momentum cannot be 0, okay? Does it make sense? I say it cannot be B because if you look at B, the graph B has a origin in the y-axis. In that point that I am, well, not in this one, but let's say that it has an original amount of momentum, let's say. I know it isn't 0. I know in B this is not 0, this is, but in here, the wavelength, if you look at in here, where the graph starts, where that curve starts, the wavelength is 0, and that cannot be, okay? So it is not B. I can tell you that it's not B. It is not B, okay? And the relationship, remember that the relationship is inversely proportional, all right? The higher the wavelength, lower the energy. So it is A. Well done. Well done. It's not a linear relationship, so it cannot be C or D because the relationship is not linear, okay? All right. All right. So let's go with question 14. A monochromatic light wave travels from glass into air. Look, if it goes from glass into air, it goes from a higher density material into a lower density material. Higher density material to lower density material, all right? Keep in mind that this is refraction, not reflection, refraction, okay? And in refraction, what is changing is the wavelength and the speed, but the energy is not changing. Why? Because in refraction, the frequency remains constant. So it cannot be A and it cannot be C. So now we have two options. It could be B or it could be D. Okay? And I just mentioned that in refraction, wavelength changes. Therefore, it cannot be B. It has to be D. Yes, of course, wavelength changes in diffraction. In refraction, of course. 100%. Think about it. Think about that in a second, okay? Slow down in here. Wave speed. Look at the camera. Look at the camera. Wave speed is frequency times wavelength. If frequency remains constant and wavelength remains constant, how the hell is wave speed changing? Think about it. Think about it. Wave speed changes because wavelength changes. You are cooked. You are very funny. A wave travels across the surface of water. The diagram shows how the displacement of water particles at the surface changes with the distance. Which row correctly describes both W and Z? Honestly, this is primary school level. W is obviously the amplitude and Z is the wavelength. So it's clearly A. I mentioned many times, you should not spend more than 1 minute in each question, but some of the questions you literally can spend like seconds, okay? I will skip this one because we reached to the conclusion that the answer in this one is wrong. Ugh, that one looks ugly, I don't like it. 18. Stationary waves are set up on a rope, length 1 meter, fixed on both ends. Which statement is not correct? The first harmonic has a wavelength of 2 meters. That one is correct because the first harmonic, the wavelength is 2 times the length. So A is correct. No names, please. We are protecting each other's privacy. Okay? Thank you. The midpoint of the rope is always stationary for an even number of harmonics. That is also correct. A harmonic of wavelength 0.4 can be set up on the rope, and there are 5 notes on the rope in the 5th harmonic. Which one is not correct? It is obviously D. Because if it is the 5th harmonic, we have so the first harmonic has 2 notes. It has 6 notes. Okay, 6 notes. So the number of the harmonic has +1 the number of notes. And people might be thinking, what the hell is this guy talking? Because you see that we still have some younglings. What is a note? So if we have a wave that looks like this, where we have 2 fixed ending, okay? All right, this is a wave, okay? In here we have 1, 2, 3 points that they are stationary. They are called notes. And this is the second harmonic. Second harmonic. So you see the second harmonic, which you have it in, for example, in a guitar, has 3 notes and 2 antinodes. So if you want to know the number of notes, is the harmonic +1. No, glass is not invisible. Glass is transparent. It's not the same thing. Invisible is that you cannot see with your eyes, but there is glass in there and you can see that. Okay? You can see that. Invisible and transparent are not the same thing. Okay? It's different. Something invisible would be air. Air is invisible. We cannot see air. But you can see a glass. Okay? A glass is transparent. All right. Okay. We are almost done. Okay? Delinquents. They are not delinquents. They are very nice. Monochromatic light is an incident. Wait a second. I didn't show you the... Did I show you the camera? No. Here. Here it is. What do you mean? We have been here for half an hour. It's 9 o'clock. I need to have a siesta. I have been awake for more than 2 hours. Anyway. Monochromatic light is incident normally on diffraction gradient that has 4.5 times 10 to the power of 5 lines per meter. The angle between the second order of diffraction maxima is 44. What is the wavelength of the light? Okay, so we need to use this formula. I'm writing it down. Give me a second. Here we go. Wait a second. Bam. This is the formula we have to use, okay? First of all, you need to know how much is D, which you get it by dividing 1 by the number of lines that we have per meter. I think you need to have it in millimeter. Correct me if I'm wrong. I'm trying to think about what we needed to do in here. We needed to do something with D. The H is killing me. No, in meter. So we leave it in meter. So it's 1 per lines per. Yes, it's 1 divided lines per millimeter. There you go. Okay, and we have. They are saying that we have 4.50 times 10 to the power of 5 lines per meter, meaning that we have 4.5 times 10 to the power of 8 lines per meter or lines per millimeter. You're driving me crazy. Okay, if it is lines per meter, we don't need to change anything. Okay, we do hello per meter. So we do D. Hello, welcome to A level. Okay, so if you could stop confusing me, I'm already very confused. I woke up very early and I am very old. So it's 1 divided 4.5 times 10 to the power of 5. God knows how much is that. I don't have a calculator. Could you please tell me how much is that? How much is 1? Let me use the calculator from Google. Calculator. So 1 divided by 4.5 x 5, that is 0.060 zeros. 1, 2, 3, 4, 5, 6, 2. All right. Yes. Is, if we want to use a standard form, is 1, 2, 3, 4, 5, 6, 7 is 2.2 times 10 to the power of minus 7. And now we use this one. They're asking about the wavelength when is the second order diffraction maxima is 44. So now we go 2.2 times 10 to the power of minus 7 times sen of 44 is equal to 2 times lambda. Guys, why you don't tell me that you cannot see anything, okay? You just tell me to move the camera. So lambda is equal to 2 times 10 to the power of minus 7 times sen of 44 divided by 2. Thank you. You could tell me earlier. By the way, the answer is B. Okay, the answer is B. The answer is B. 4 lambda is 416 nanometers. Okay. Check. It will give you the answer in times 10 to the power of minus 9. It's fine. But the answer is B. Okay. Did you all get B? Nobody got B because you are not paying attention. You're not even writing it in the chat. What an absolute shame. Exactly. Look, guys, they are telling you to focus. Look, they are answering the question, guys, and you are not answering the question. What an absolute shame. Yes, I'm 100% sure. Yes, 100% sure. Check your calculations, please. It is. You got 770. Do I have to check the marker scheme? Is that happening to all of you? Or is just CG Man is getting 770? Because the market scheme is saying for 416. So I haven't done the calculations. I'm gonna be honest. I don't have calculator, but well, if my boss David says that it is 416, it is definitely 416. Okay, we are gonna trust. We are gonna trust in the boss David and the boss Proceed Stars. Let's continue. We have been here for 37 minutes. 3 minutes more, and I promise I am going to bed. Okay. This is about moment, okay? And it's quite easy. You just need to do moment time distance and to see if it is balanced, moment clockwise and moment anti-clockwise, they have to be balanced, okay? I will leave it you to try to do a different time. This is mechanics. No. This one is something we can do. A particle of mass m undergoes simple harmonic motion with amplitude A and frequency f. What is the total energy of the particle? Wow, that one is difficult. That one is difficult. The energy of the particle and the amplitude. Oof. That one is not coming to my mind now. How is the relationship between amplitude and... Okay, I will do number 24 later on my own when I'm not looking at the chat and see the discussion that's happening in there. Ah, okay, fine. So it's also mechanics. I was thinking in terms of waves. I was thinking, okay, fine. All right, so this is also mechanics. Mechanics is about springs, electricity, horrible topic, I hate it. Electricity, horrible topic, I hate it. Disgusting. And that's all. Ah, lucky me. The paper is over. All right. Good. So wonderful revision session, right? Yes, we are definitely done, okay? Just for those who don't know, I don't teach all the topics in A level. So there is another teacher who teaches the other topics in in A level. I only teach in year 12 particles and waves, and the other teacher teaches mechanics, materials, and electricity. That's why there are certain topics I skip them. Okay? Alright? Alright guys, it has been an absolute pleasure. Now we will all give our best luck to our year 13 students who have physics exam tomorrow. Could we please all write in the chat, good luck tomorrow? Yes? Can we all tell them good luck? And tell them how we are all very proud of them? I will be in the common room before the exam, okay? And I will be in the lineup. Make sure you don't cheat, please. Alright guys, has been an absolute pleasure. I have been here for quite a long time today. I hope I didn't get everyone bored. See you tomorrow. Revise a little bit before going to bed. Wake up early. Don't stay all night studying. You need to be rested. And see you tomorrow in the lineup. Ciao, ciao.